So here we have problem number 4. A flask with volume of 1.21 liter provided with a stopcock contains ethane gas at 294 Kelvin. An atmospheric pressure is given. The molar mass of the ethane is given. The system is warmed to the temperature of 385 Kelvin with the stopcock open to the atmosphere. The stopcock is then closed and the flask is cooled to its original temperature. How many grams of the ethane remains in the flask? Okay. So what we have? So basically we have the volume of this tank is given. Okay, the liter is converted into meter cube. Then initial temperature is given 294 Kelvin. The atmospheric pressure is given outside. The molar mass is given of this substance. Then they increase to the 385 and then make it open this one. Okay, so they make it, just a moment, they make it open and then they increase it. Okay, then you have to find how much mass is left inside this container, and then we have to find what will be the pressure inside. Okay. So first of all, we have to use the ideal gas law formula, which is PV is equal to nRT. Initially we have to know how much substance is there. Okay, initially when temperature is 294. So at temperature initial, you can find N1. So we calculate how much is there, and then we can find that it is this amount of mole is there. But however, when they increase the temperature and when they left it open, definitely some of them will escape, and then some of them will remain. That means it will be less than initial temperature. Okay, amount of substance. Then after that, what we do, we take this one. Okay, then we try to calculate also the temperature final and how much is left there. Again, we use this formula, molar mass, so then N2 is equal PV RT final, and then we know that this is amount of equal to this one. So that means after increasing temperature and leaving open, the mole, it will be decreased and it will remain as it is. Now what will be the pressure 2 or pressure final? How can we find it? So the N is equal M over molar mass. So from there, using the second one, we plug it here and we find that this is equal to the 1.153 grams. Okay, then this amount. Okay, so basically I think there is a closest one. So basically we found how much mass is left inside the container when temperature increased and valve is open. Now what about will be the pressure inside this thing? So pressure inside of it will be using this ideal low gas formula, and then we found N2 from equation, and then we have P final. Volume is constant because volume is not changing. So we substitute numbers. First we found N2, and then after that we use P2 or P final, we substitute there, and then we get this amount of pressure.